Hi friends, welcome back to Edupedia world. In the last lecture we started discussing about calorimetry and we saw what is heat and temperature. Today we will focus on other aspects which are heat capacity. What is heat capacity? What is specific heat capacity? We'll understand those terminologies and understand the inherent meaning of them, and then using those concepts we will solve some numericals. So let us get started with today's lecture. We will begin today's lecture by understanding what is heat capacity. Heat capacity. Heat capacity is also known as thermal capacity. Thermal capacity. So what does heat capacity mean? You might have noticed that to heat a material, a particular body from a particular temperature to a higher temperature depends on the body. Different bodies will require different amount of heat to raise the temperature by the same amount. So this is exactly what is represented by heat capacity. How much heat is required by a body to raise its temperature by 1 degree Celsius. Okay, so let us define it. Heat capacity is the amount of heat energy, required to raise its temperature by 1 degree Celsius or 1 Kelvin. Why can we interchange between 1 degree Celsius and 1 Kelvin? Because the amount of temperature rise when we rise the temperature by 1 degree Celsius is same as the amount of temperature rise when we rise it by 1 Kelvin. Okay, so the size of a degree in Celsius scale and Kelvin scale is the same. Therefore, we can either say that the rise of temperature is 1 degree Celsius or we can say the rise of temperature is 1 Kelvin. So the point to be noted here is that specific heat capacity is amount of heat energy. It is the amount of heat energy to raise temperature by 1 degree Celsius. We know that here there is nothing to do with mass. It is any body. Suppose your whole house. How much heat is required to raise the temperature of your house by 1 degree Celsius is the heat capacity of your house. Or alternatively, how much is the amount of heat required to raise the temperature of a bucket of water in your house? That is the heat capacity of water or the bucket of water. So heat capacity has nothing to do with mass. Okay, now let us write the formula for heat capacity. So heat capacity of a body can be defined as heat capacity is the total amount of heat required, the amount of heat energy given upon the rise in temperature. Delta means the change and T represents temperature. So how much temperature change is caused by Q? That ratio will give how much heat is required to raise the temperature by 1 degree Celsius. So this is the mathematical representation of heat capacity. Heat capacity is sometimes denoted by C dash. Okay, Now let us see what are the units of heat capacity. Units of heat capacity will be the unit of heat energy is joule, and the unit of change of temperature is the same as the unit of temperature, which will be Kelvin. So unit of heat capacity is joule per Kelvin or joule per degree Celsius. And if the heat is given in calories, then it will be alternatively calorie per Kelvin or calorie per degree Celsius. Okay, or kilocalories. We can express it in whatever units is convenient as per our requirement. But it is basically the unit is unit of heat energy upon the unit of temperature. So now that we have an idea about the heat capacity, let us see what specific heat capacity means. Specific heat capacity. A point to be noted is that in heat capacity, it is not a material property. You have one bucket of water which is 1 kilogram, and you have one bucket of water which has 5 kilogram of water. So the heat capacity for the 5 kilogram of water will be 5 times that of 1 kilogram of water. So using heat capacity, we cannot pinpoint the kind of material that there is, because more the mass, more will the heat required. That is precisely where the specific heat capacity concept comes into. Specific heat capacity is a material property. This is a material specific property. If you recall, I just touched upon briefly on this terminology in the last lecture. Now let me first define what specific heat capacity is. Specific heat capacity is again the amount of heat required, the amount of heat required to raise the temperature of 1 gram or 1 kilogram of a body by 1 degree Celsius or 1 Kelvin. So let us see what difference is there in this definition than the heat capacity definition. Here too, the definition begins with the amount of heat required, and that rise in temperature is also 1 degree Celsius. But it specifies that this is the amount of heat required to rise the temperature by 1 degree Celsius for a unit mass, which can be 1 gram in CGS unit or 1 kilogram in SI unit. So specific heat capacity specifically focuses on the unit mass of a body. It is the amount of heat required to raise temperature by 1 degree Celsius for a unit mass of the body. Heat capacity did not have anything to do with mass. It was just the amount of heat required to raise the temperature of any body by 1 degree Celsius. Specific heat capacity, on the other hand, is amount of heat required to raise the temperature by 1 degree Celsius for a unit mass, 1 gram or 1 kilogram of a body. Okay, so now let us see the mathematical representation of this. Specific heat capacity, sometimes represented by a small c, is the total heat, which is Q, divided by unit mass. So per mass per temperature rise. So heat required per mass per degree Celsius rise. That is the specific heat capacity. Can be easily demonstrated as M delta T. So alternatively, what we can say from this is that the heat required to raise the temperature of m units of mass per body by delta T will be C into m into delta T. So Q is C m delta T just by taking it here, which is precisely the relation which we found at the end of lecture in our previous lecture, that the heat required to raise the temperature by delta T for a unit of for a body of mass m was Cm delta T. Okay, now that we know the definition, we know the difference between heat capacity and specific heat capacity, let us see what are the units of specific heat capacity. Units, we can very easily derive it from this definition. So the unit of heat content is joule again, and in the denominator we have mass and change in temperature. So the mass will be, we can say it to be kilogram, and the unit of delta T is Kelvin or degree Celsius. So joule per kg per degree Celsius or joule per kg per Kelvin, or calorie in case the values are given in calories, calorie per degree Celsius per kilogram or calorie per kg per Kelvin, or in CGS unit we can use grams in case instead of kilograms. So these are different representations how we can express the units. Okay, so now we have an idea about the heat capacity and the specific heat capacity. Let us see what is the relation between heat capacity and specific heat capacity. We know that the heat capacity is Q by delta T and specific heat capacity is Q by m times delta T. So what we can do is we can write C is equal to 1 upon m times Q upon delta T, and we know that Q upon delta T is heat capacity, so we can replace that as C dashed upon m. So what we get is that the specific heat capacity is heat capacity per unit mass, which was kind of obvious from the definition that it had to be this. Okay, now we have seen a lot of heat capacity and specific heat capacity. Let us see some sample values of specific heat capacity for some day-to-day materials. Specific heat capacity, as I already said, is a material property. One of the day-to-day material that we encounter every now and then is water, and water is known to have one of the highest specific heat capacity. What is the specific heat capacity of water? I will represent it as C water. It is approximately 4200 joule per kilogram Kelvin. So for water to raise the temperature by 1 degree Celsius or 1 Kelvin, for 1 kilogram of water we need 4200 joule. Now an interesting idea is that the specific heat capacity depends on what state the material is. Here water is the liquid state, but if we see the specific heat capacity for ice, it turns out to be 2100 joule per kilogram Kelvin. So the specific heat capacity of ice is kind of 50% of that of water, and the specific heat capacity of steam is known to be around 460 joule per kilogram per Kelvin. So we see that the specific heat capacity is material property, but it also depends on what state the material is in. Okay. Now you can get standard tables which will specify the specific heat capacity for a lot of different materials. I'm not going to go into those details. You can have a look at them in standard textbook, or you can just Google to know out of interest. This is you need not learn those values. If a question needs those values, it will be given in the question. For water, you can learn it because it is a very common thing, and a lot of physical phenomena is explained just by using the specific heat capacity of water. Note that specific heat capacity of water is a very, very large value compared to other materials. The specific heat capacity of hydrogen is known to be the highest. It's somewhere around 14,630 joule per kilogram Kelvin. But that's just a trivia. You might not need to remember that. Okay, now let us see a numerical and understand and cement our whole understanding of today's lecture. Let us do a numerical. The question states that we need to find the heat required. What is the heat required to raise the temperature by 10 degrees Celsius for 5 kilogram of water? So what are the given things? We know that the mass is equal to 5 kilogram. We need to raise the temperature by 10 degrees Celsius. So delta T is 10 degrees Celsius. And we are given that the specific heat capacity of water is 4200 joule per kilogram degree Celsius. Okay, now we need to find the total heat required to do this task. We know that the heat required is equal to mass into specific heat capacity into the rise in temperature. This is the definition that we studied. This is from the definition of specific heat capacity. So we need to just replace the values. Mass is 5. Specific heat capacity for water is 4200. And the rise in temperature is 10 degrees Celsius. So when we calculate this, this will give us 210,000 joule. So we require 210,000 joules of heat energy to raise the temperature of 5 kilogram of body by 10 degrees Celsius. 5 kilogram of water by 10 degrees Celsius. So this is basically what the question demands us. What is the heat required? Now once we have the total heat required, we can easily calculate what is the heat capacity of the body. There are two ways to calculate the heat capacity of the body. One is by using Q. Let me do that. We know from the definition of heat capacity that heat capacity is amount of heat required to raise the temperature of a body by 1 degree Celsius. So heat capacity is Q upon delta T. Now we have Q as 210,000 joules, and we know that the rise in temperature was 10 degrees Celsius. So 10 degrees C, this will be joule, this will be degree Celsius. That will give us 21,000 joule per degree Celsius, or 21,000 joule per Kelvin. What this means is that the heat capacity, the amount of heat required to raise the temperature of the whole bulk of body by 1 degree Celsius is 21,000 joules. So this is one way when we know the total heat required. We can alternatively find the heat capacity by using the relation between heat capacity and specific heat capacity, which is what? Heat capacity C dash is equal to mass times specific heat capacity. This is the relation which we developed at the end of our lecture. If we use this, what will we get? Mass we know is 5 kilogram, so it will be 5 kg, and specific heat capacity we know is 4200 joule per kilogram per degree Celsius. So that will be 4200, and that turns out to be exactly equal to 21,000 joule per degree Celsius, which is same as this. So these are two alternative ways. One is by using the total heat required, and one is by using just the definition of relation between specific heat capacity and heat capacity. Okay, with this example and discussion about heat capacity and specific heat capacity, I hope that you have a picture about how these things work, how the relations are and how they interact with each other, what is the relation with specific heat capacity and heat capacity, between heat and heat capacity and specific heat capacity, what is specific heat capacity of a material, and that it is a material property and such stuff. In the next lecture, we will discuss about principles of mixtures, and we will solve numericals on that. In that we will require these concepts that we developed in today's lecture. So just revise through today's lecture before jumping into the next lecture. Till the next lecture, have a great day. Goodbye.